Welcome to Fantastic Stories. As we haven't discovered extraterrestrial life yet, imagining how aliens may look like on different planets involves speculation based on the environmental conditions of those planets. Let's try to imagine how alien life could potentially adapt to various conditions, considering factors like gravity, sunlight, and the presence of water. How may aliens potentially look like? To imagine how aliens may potentially look like, we need to consider several types of environmental conditions, which are crucial for the evolution of alien life forms. Planets with lower gravity. For example, a moon-sized planet. On a planet with lower gravity, organisms might be taller and more slender, as the gravitational force would not pull them down as strongly. Aliens could have long limbs and lightweight, delicate structures. They may resemble Earth's insects or arachnids, but larger and more elongated. Also, wings could be more common, enabling easier flight in the lower gravity, as they may be able to glide or float in the atmosphere. Planets with higher gravity. For example, a super-Earth such as Kepler-22b, a rocky world with strong gravity. On a planet with higher gravity, organisms would need to be sturdier and more compact to withstand the increased force. Aliens could have shorter, stockier builds and strong, dense musculature, and reinforced, thick skeletal structures to support their weight. They would be more robust and squat, with limbs designed for stability and strength. The movement might be slower and more deliberate. They would have strong, clawed limbs for gripping the ground and a lower center of gravity to prevent falling. Planets with more sunlight. For example, a planet orbiting a large star, like a blue giant star. Organisms on such worlds would need protection from very intense UV radiation and bright light. The organisms would need protective outer layers to shield them from the radiation. They would need thick skin or scales, perhaps metallic or highly reflective, to deflect the radiation. Their eyes could have protective membranes or some advanced ocular structures to filter and control light intake. Photosynthetic organisms may have developed highly efficient pigments, different from the Earth plant's chlorophyll, to make the most of abundant sunlight. Moreover, organisms could be more nocturnal to avoid peak radiation levels. Planets with less sunlight. For example, a planet orbiting a red dwarf, like Proxima Centauri b. Organisms on such planets would need to adapt to lower light conditions due to a dimmer star and to longer day-night cycles. They would need large eyes or other light-sensitive organs to maximize the intake of limited sunlight. Some organisms might rely on echolocation or non-visual senses, or have other enhanced sensory organs for detecting minimal light. They could use bioluminescence for communication or attracting mates. Photosynthetic organisms would be dark in color to absorb as much light as possible and to utilize the optimal light wavelengths. As the light spectrum would be skewed toward longer wavelengths, meaning reds and infrared, the vegetation might be purple or black instead of green. Rocky planets. For example, Earth-like rocky planet or Mars-like planet. The environment would include varied types of terrain with mountains, plains, and deserts, possibly with the presence of water or other liquids, or rather a dry and dusty desert surface. Potential appearance would include land dwellers with limbs designed for walking or climbing. It may also include burrowing or underground creatures adapted to escape surface radiation and conserve moisture. Aliens would have thick skin or exoskeletons to protect against the weather, with elaborate adaptations for minimizing water loss. Potentially, they would be nocturnal to avoid daytime heat. Species may range from small, nimble creatures with camouflage abilities to large, armored herbivores or predators, much like on Earth's dry environments or deserts and savannas. Oceanic planets, for example, water world or icy moons like Europa or Enceladus. The environment would include a planet entirely covered by a deep global ocean, possibly beneath a thick ice layer with no direct sunlight. Potential appearance would include streamlined bodies for efficient swimming and gills or other specialized organs for extracting oxygen from water. That is, if they even use aerobic breathing, aliens would have large, sensitive eyes for seeing in the dark and murky water, or would be blind with reliance on other senses, such as echolocation for navigation and hunting. Similar to some creatures from Earth's deep oceans, bioluminescence would probably be used for communication, mating displays, or luring prey. Similar to Earth's deep sea vent ecosystems, organisms living near geothermal vents may be using chemosynthesis rather than photosynthesis for energy assimilation. Planets with alternative basic liquids instead of water, like methane, for example, the moon of Saturn, Titan. This harsh world has a cold surface with lakes and rivers of liquid methane, ethane, and a thick nitrogen atmosphere. Aliens would potentially have thick, insulating outer layers to retain heat in extremely cold conditions. Due to lower temperatures, life forms may also have slower metabolic rates and longer life cycles. However, their life functions would be based on different biochemistry, as their cells and biological processes would be adapted to function in liquid methane rather than water. Therefore, such methanogenic life forms using methane as a solvent instead of water are hard to even imagine. These are just a few speculative examples illustrating how alien life might have evolved to thrive in a variety of distinct planetary environments, reflecting the vast possibilities of life beyond Earth. But until we discover alien life, these examples remain pure speculation and more of a thought exercise. Thank you for watching. If you enjoyed the story, consider subscribing to my channel. Have a great day and see you next time.